We have discussed about linked list, na? Linked list. So in last class we have discussed what are the disadvantages of array, and to overcome those disadvantages, how we can use the scattered memories in such a way so that we can finally get some list by linking the scattered memories. So that's why it is called linked list. Now we have also seen that in linked list the memories are in a form of node, okay, in a form of node, where one part of the node is actually used to connect to the next such node, okay, and the rest is used for storing the data. So this is for storing the data, and this particular part is for linking the next such node. So if this is my RAM, suppose this is my RAM, which is divided into segments. This is one free space, I'm marking with red. There is another free space, there is another free space, another free space, another free space. So these are the different free spaces. Okay, so how to make them a single list? By connecting. So there is one part which is link part in this particular free memory. This will point to the next free memory. From this free memory, one particular part will use to point to the next free memory. From this free memory, one particular part will use to point to the next memory. And in this way, it will create a single list. Since all the memories are linked together, so that's why it is called linked
That was done.
list.
What we were doing that day. So you can like continue.
So this is linked list. So in last class we also seen how to define a node. How to define a node, since a single node is not an individual thing, it is a combination of data part and link part. So we need user defined data type. So we need structure. So we have seen how to define a structure for a particular node. Struct node, okay. Then inside this we require data. Data may be in any data type, that's why I'm writing T. So this is one particular variable dt for storing the data. And the next part is the link part, which is actually having the address, of the next memory, or you can say, not for this particular example it is memory, but the address of the next node. So what is the type of the node? The type of the node is this one. So the type of, so obviously since this is an address, so it should be represented using a pointer. This is the definition of pointer: variable which can store the address of another variable, so it is called pointer. So we required a pointer. So obviously this link part is nothing but a pointer. What is the type? Since it is pointing to a node, so its type is also node type. So I will write it struct node. Okay, so this is my structure, and this type of structure is called self-referential structure. Because why it is called self-referential structure? Because the structure pointing to same type of structure, so that's why it is a self-referential structure. Okay, so now today we will start with what are the different types of linked list. First, the different types of linked list. Okay, now there are linear, then circular, and then doubly linked list. So these are the three types of linked list that is available in our data structure. Okay, Now, what is the meaning of linear data structure? It is a line. There must be a starting point. So line means there must be some starting point and ending point. Correct? Then it will become a line or linear linked list. So normally the picture of linear linked list is like this. If you want to draw a picture of linear linked list, it will be like this. The starting point, which is called the head pointer, then the first node, head pointer is pointing to the first node pointing to the second node pointing to the third node. If there is no more node or free memory, then it will point to null, ground symbol. So this is the picture of linear linked list, starting with some pointer variable head, ending with null. So this is nothing but null pointer. So this is the picture of linear linked list. Now, how the picture of a circular linked list? How to draw a circle? Starting and end point same start and end point. Then we say it is a circle. So same for circular linked list. So this is the first node. This is the head pointer pointing to the first node. Then the next node, which is pointing to the next node. Then since this is the last node, so this will again point to the first node. So there is no, so see, both head and last node are pointing to the first node. So the same start and end point. So this is the meaning of circular linked list. There no null pointer. Clear? Now for some, now if you see carefully that in case of linear linked list, what is the drawback? The drawback is, suppose you are in this particular node. Suppose my position is in this node. I want to move into this node. This is not possible. This is not irreversible, because there is always a forward movement. From this node we can move somewhere in the forward direction, but there is nothing for backward direction. Backward movement is not possible. So that's why if I want to this previous node, again I have to start with this node. So this is one drawback of linear linked list. To solve that problem, we have come with circular linked list. Suppose in circular linked list you are in this particular node. You want to get back to this node. How you can do this? From there you can move into front, then from there you can again move into the. So there is a chance that you can reach to the previous node by completing the whole circle. Okay, still it is difficult. Why? Because suppose there is 100 nodes in this linked list and you are in 100th node. You want to reach 99th node. Then by get back to first node, you have to traverse 98 nodes. Then only you are able to reach to the 99th. So this is a little bit difficult or time consuming. Okay. So therefore, there comes the last one, doubly linked list, where you can move not only in forward direction but also in the backward direction. It means each node having a forward movement pointer as well as a backward movement pointer. It means in case of doubly linked list, the node structure becomes a little bit difficult. Instead of one pointer variable, in doubly linked list there are two pointer variables, one data and two pointer. One is for next or forward, another is for previous or backward direction. Two pointer variables. So your structure becomes like this. Struct. If you want to draw a picture like this, first member is a pointer, next is a data, third is again pointer. So struct d node, if I say doubly linked list node, d node, then it will point to same type of node. So I will declare a pointer variable prv, previous, then any type of data, it can be integer, float or character, that's why I'm writing t. Then again, struct dnode, this is the new type of node, star next. So this is the picture of this type of doubly linked list. So now in case of doubly linked list, this is very interesting. Another thing, in case of circular linked list, only clockwise movement is possible if you use forward pointer. Okay. Now in case of doubly linked list, it again divided into two types. One is called linear, or you can say linear doubly linked list. Okay. And another is circular doubly linked list. Now the picture of linear doubly linked list will be like this: first node, second node, third node. Okay. Now let us assume the address of this node is, say, alpha, this one beta, this one gamma. Okay. So this is the head pointer. What value inside the head pointer? Obviously head pointer will point to the first node, so obviously alpha is there. That's why this is pointing to this. Okay. Now this is a doubly linked list, so two pointers variables, one data part, two pointer variables, one data part. This will point to the next, so there is beta, that's why this is pointing to this. Okay. Now this one for forward or next, so this is pointing to this, it means this one having gamma. Okay. Now normally this pointer, first one, is pointing to previous node. See there, for the first node there is no previous node, so this becomes null. Similarly, for the last node there is no next node, so this becomes null. And this one is pointing to the previous, it means there is alpha, that's why this is pointing to this. Now this node will point to the previous node, so the address of previous node is beta, so there is beta, that's why this is pointing to this. Okay, so it is a forward and backward both direction. So if you are in this node, this particular node, you want to reach to the previous node, you can access the previous pointer to reach to the previous node. If you are in this node, you want to move forward, then use the next pointer, this one, to move forward. So here both backward and forward movement is available. Okay, and this is the head pointer. Now what happened if it is a circular doubly linked list? So in normal circular linked list we only have one direction, that is either clockwise or anti-clockwise. But in case of doubly linked list, the picture is little bit uh, difficult, but try to understand. So these are the addresses. So this is the head pointer having alpha, that's why it is pointing to the first node. This will point to the next node, so there is beta. Okay, this is pointing to the previous node, so there is alpha. Okay, this is pointing to the next node, so there is gamma. This will point to the previous node, so there is beta. Okay, this one will point to the first node, so there is alpha. This will point to the last node, so there is gamma. So this is the picture of circular linked list. See, if you use the forward address always, this one from there to there, this one there to there, this one there to there, so it is a clockwise. If you use the backward address, this one, it will move from there to there, then backward from there to there, backward there to there, so it will access in a anti-clockwise. So both clockwise and anti-clockwise direction is possible using circular doubly linked list. So this is the picture of circular doubly linked list. Remember, in case of circular whatever or doubly or linear, there is no null pointer concept. But if it is a linear linked list, doubly or single, so you can say that this linear linked list or circular linked list, you can say they are singly. This one doubly, this one singly, single address. Okay, so these are the different types of linked list. Now, since it is a lab class, so what we will do in this lab class, we will first create one linear linked list. Simple. The, the simplest one, the linear linked list. So the picture will be like this. H, the head pointer. This will point to the first node. In the first node data part, I will store some data, suppose integer data. Then it will point to the next node. In the next node, I will store say 3 data. Then it will point to the next node. In the last node, and this is the last node. And in this last node, I will store data 11 and it will have null point. So I want to make a picture like this of 3 nodes. I can create any number of, because this is dynamic. I've already told you last class, array is static, size is fixed, but linked list is dynamic. It means we can increase the size whenever we require. Okay. So the first thing that we have to do, we have to declare a structure. Okay. So struct. So let us name it LD. LD is the name of the structure. LD, linear, not LD, better L node, linear node. Better write it L node, not so L node. Okay, linear node. So what are inside this? We are storing integers. So data part is int, variable name, member name dt, and next one is a link part, which is point to the next structure. So struct L node star say LK. LK is the link part. So the first thing that you have to do, you have to declare the structure. So this is declaration of a node linked list node structure. Done. Okay. Now what we have to do, we have to create step by step. First, we will declare a head pointer. If we don't initialize the head pointer, it will point to anywhere. So we will initialize the head pointer with null. So this is our first step. Then in the next step, what we will do, we will allocate a memory dynamically for a node. This memory will be allocated dynamically. Then the starting address of this allocated memory will be stored into H. Suppose the starting address is alpha. So I will store alpha here. It means this link will be gone and it will point to this. Okay. So this is first step. Now this is the second step. Then what we will do, we will store some data in this position. What is data? We require 5. So how to access? So we know that this having two parts, one is dt, another is lk. And if you remember last class that I repeatedly told you that the name of this member with respect to the pointer which is pointing to this will be h arrow dt. Whatever pointer pointing to this node, the member name will be according to that pointer, h arrow dt, and this one will called h arrow lk. Remember this. So what I will do, if I have only one node, suppose I have only one node in my linear linked list, then what I will do, I will put here null, correct, and I will put some value here. So suppose I am putting some value here, say x, which x I have already taken using some scanf. So x is some scanf value, integer value, which I have taken, which I have now stored into this particular position. Then since this is the first node, this becomes null. So this is the first thing that I have to do. So step 1, h initialize with null, then a memory is allocated, then the data part of this memory is assigned with some value, then the link part of this data is initialized with null. Why I am putting null here? Because I have no idea how many node I'm going to create. If suppose I want to ask the user in each and every step, do you want to create a node? If he say yes, then only I will go for creation. So if after this the user don't want to create any node, that's why I have used the null. Now if user want to create another node, what I will do? I will again allocate some memory, okay, with malloc. Then the starting address, suppose the starting address is beta, I will store the starting address in this position. So beta will be stored here. How I can do this? What is the name of this pointer? This pointer name is h arrow lk. So I will put it like this. Then this is no more null. This will point to this node. Now, with respect to this pointer, what is the name of this pointer? Where I have stored beta, the name of this pointer is HROLK. Now, since this HROLK is pointing to this, so with respect to this, what is the name of this? This will become HROLK arrow LK. If this HROL key, if we consider this HROL key is X, then this becomes X arrow LK. So what is X? X is HROLK, so it becomes HROLK ROLK. Similarly, this one HROLK, sorry, this one HROLK DT and this one HROLK LK. So this DT part will be initialized with some X value taken from user, and this link part will now again become null because this is the last one. So in this way I will repeat. So this whole thing will be repeated again and again. See, one drawback of this repetition is every time one link part will be added with this HROLK. So if I add say 5 node, I have to write HROLK ROLK 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 DT. The number of LK arrow will be increased. So how can I do this? Since it is a repetition, I will use one third variable or temporary variable to assign the last node pointer, to assign the last inserted node pointer. Then with respect to that temporary variable, I will try to access the next one. Okay. Now see how I will code it. So this is my structure. Obviously, I will use the structure outside the main function. Then inside the main function, the first thing that I have to do, I will declare some variable. The first variable that I required is h, head pointer. So struct. Okay, before that, I can do another thing. See, every time I have to write the new data type, which is struct lnode. Okay. So instead of writing every time struct lnode, we can uh, type def it with a smaller name like this, type definition of struct lnode ln. So the new name of type definition of struct lnode now becomes ln. So no more we have to write struct lnode. Instead of writing struct lnode, we can just write ln, which is nothing but the struct lnode, which I have already typed it. So this is a keyword which is used to type definition. So I am giving this type a new name ln. You can do it like this also. Suppose you want to change the type definition of float. So you have to write it like this: type def float, or float I want to write capital F only. So after writing this, if you write fx, it means x is a float type variable. No need to write float again and again. I have given float a new type definition, that is it. Similarly here, this is our new user defined data type struct lnode. We have type def it to ln. So no more we have to write struct lnode. Now we can combine these two. We can combine these two in a single one, and it will look like this. It will look like this. Just giving another small version of this. You can write it direct like this: type def struct L node. Okay, then inside this integer dt, and then struct L node star lk ln comma. So you can type div after declaring the structure, or when you are declaring the structure at the same time you can also type div. So this will reduce the writing. It will, if you write it in this form, it will reduce your writing a little bit. Okay, so this part is done. We have given a new name type definition for our structure. So I have to declare a head pointer. Okay, pointer, and it should be initialized with null, remember this. Okay, and then we require two more pointer variables for other purposes. Let us name it not tp, let us name it new. Okay, new. So I have declared three different pointer variables. One is h, another is t, another is new. Okay, now then I am declaring some, since I want some choice from the user, so I am using some choice variable integer, and then x for taking the input, data input. Okay, okay. So after this, I have already told you that this is a dynamic memory allocation, and depending on the user I will allocate some node. So I will write how to write this. So I will use a do while loop. Okay, then I will write a printf statement and ask the user, do you want to create a new node? Then I'm also asking, enter 1 for yes and 0 for no. I am giving this instruction to the user. Then I am taking the input from the user, whether user want to create a new node or not. Okay, so %d, this I will store in my choice variable. Done. Okay, okay, better writing this in this way, I can better go for this will be better. Okay, so hash include, these are the mandatory things, stdio dot each, sorry, okay. Then since I have to use malloc calloc, so I am using uh, stdlib dot h also. Okay, then I will declare the structure. So type def, the smaller definition. So struct l node, sorry, yes, no problem. Then inside this integer dt comma, then struct l node star lk, this is the pointer. Okay, so this is the uh, end of the structure, and then the new type definition ln. Done. Okay, then I will start my main function, int main. Okay, Then inside this I will declare the variables ln type variable star h head pointer, which will be initialized with null, comma one temporary pointer and another new pointer. So okay, then I required integer variables for choice, taking the choice from the user, and for taking integer input. Okay, then I will start the do while loop. I will start the do while loop. So printf, first giving the instruction to the user. What is the instruction? The instruction is, do you want to create a new node? Question. And then another new line, enter 1 for yes and 0 for no. Okay, so this is a simple instruction to the user whether he want to create a new node or not. Then I will take the input, the choice from the user, %d ampersand ch. Okay, then if your choice is 0, see, if your choice is 0, then no need to create a new node. So I will break. Is it clear? I hope it is clear. If your choice is 0, then no need to go for node creation. So what I will do, I will break the loop. Okay, break, done. If my choice is not 0, then what will happen? So then a new node will be generated. So that's why I have taken the pointer new. So I will call the new pointer to allocate the memory. Now see, there comes another interesting part. So here I have to call malloc-calloc. If you remember how to call malloc-calloc, then the format of malloc-calloc is, first you have to give the typecasting. Means if you want to check the format, then the format is like this: void star, this is the format, malloc. Okay, then inside this I have to provide the number of elements. Sorry, for malloc I have to provide the size, how many elements in size. So this is the format of malloc. So what malloc is doing, malloc is allocating a size bytes in heap memory, then it will return the starting address, then it will return the starting address. Why it is using void pointer? Because void pointer can be used or can be allocate any type of address. That's why it is using void pointer. Now see, here new is not a void pointer, new is a type of ln pointer, so I have to typecast it. Okay, so the final format of this will be like this: ln star malloc, then I will create a new node. So size of, what is the size of the new node? It depends on the type of the node. Ln is the type. So this is the new node I have created, and the address is now new. So which one is pointing to the node? New pointer is pointing to the node. So the next thing is printf. I will ask for enter data, enter data. Then scanf, I will take the data part, comma ampersand. So this is data part I have taken. Then how to access the pointer or data part? dt, new arrow dt equal to x. And how to access the link part? New arrow lk equal to null. I have already told the first thing, first time I have to create a node, I will make it null. So this is a new node creation, this whole part from there to there, from this new malloc to up to this new lk equal to null. This is the new node creation with data. Now what I will do, I will put it in the linked list. Okay, so I will check first, I will check whether my linked list is empty or not. If my if my linked list is empty, means if the h is null, then my linked list is empty. Then what I will do, so this node, the new node which I have created previously, will become the first node. So I will write it h equal to new. Okay, and then I will set a temporary pointer in this head node. This is the thing I have to do if this is the first node. Okay, else if this is not the first node, then what I will do, if this is not the first node, then I will write it like this. So now t is pointing to the last node. T is pointing to the last node. So I will write it like this: t arrow lk equal to new. Okay, and t becomes t arrow lk. These two things I have to write if this is not the first node. Okay, and after this is the end of our creation, and I will write the while part for this do while loop, this infinite loop, but it will be stopped if the choice is 0. Okay, so after this what I have to do, this is the creation part. This whole thing is the creation part. This is I have created using the do while loop by asking the user, do you want to create a new node again and again, and this is the end of the creation. Then after creation what I will do, I will try to print the data. I will try to print the data. So better again move into this. So what I have done in there, so I have write it like this, if you remember: new equal to ln star malloc size of ln. So there is only few seconds left. Please rejoin after disconnection. So I have write it like this. So if I write a statement like this, what is the meaning of this statement? The malloc will allocate some memory. So suppose malloc allocated this memory. Okay, what is the size of this memory? Obviously integer data and then integer address. So if I consider integer as 2 bytes, so it is a 4 bytes memory, and the address is returned to the new.